Nice to meet you. Thank you. So what arm do we have here?
This is the ROMER 7-axis absolute arm with fully integrated RS1 laser scanner. This is a 7-axis arm, so I have one additional axis of infinite rotation and a pistol grip that lets me freely rotate the laser scanner when I'm measuring.
And you need that 7th axis if you're doing scanning, right?
That's correct. Right. It's very helpful.
Yeah.
And this arm has the same absolute encoders that Scott talked about earlier, where I can just go ahead and start up the computer, power up the arm, and I'm ready now to start scanning. Okay. I don't have to wait for the scanner to warm up either.
Now, what's the advantages of an integrated scanner as opposed to one that clips on?
Ease of use, and the advantage of this is that it's calibrated at the factory. The entire system is calibrated as a unit, arm and scanner together, and fully certified at the factory as well. The accuracy of this laser scanner is 30 microns. That's just a little more than 2/2000ths of an inch. And the accuracy of the entire system is 63 microns, which is 2.5 of an inch.
Well, hey, that's the joys of broadcasting live from a show floor. You just don't know what's going to happen. We lost power there for a couple minutes, but we're back. And by the way, battery-operated ROMER arm, it's still there. The data's still there. We haven't actually lost anything, have we?
No, I'm all set, ready to go.
Well, let's continue from where we left.
All right, I'm ready to begin scanning. And the piece that I'm going to scan today is a winglet body part from a Red Bull Formula One racing car.
Okay, terrific.
So I'm going to step around here. And the software that we're using is PCDMIS Reshaper. It is a 3-dimensional point cloud processing software that I can use to generate a high quality mesh and to create surfaces and B-splines that I can export to a CAD model.
Okay.
So what I'm going to do is I'm going to come over here and I'm just going to select my Measure Digitize button and walk around to the part that I'm going to scan. And you can see that the laser scanner is active right away.
Right.
And this is a highly reflective piece. So what I want to do is to capture how much this material reflects back the laser line. And the ROMER Absolute 7-axis arm with the integrated RS1 scanner can do that with one click of the button. So I'm just going to position the laser line on the piece and click a button, and you'll see in the lower left-hand corner of the screen that the system has automatically calculated the correct exposure and laser power based on this material, and it's changed the setting on the scanner.
Okay, so what you're saying is that if you change surfaces, you can just push a button and it will automatically set its sensitivity to the reflectivity or the color of that surface, right?
That's correct, Dirk. Okay. And I can also do that right when I'm in the middle of scanning. So if I scan a part that has different types of materials on it, with just one button click, I'm now set to the new material and I can just keep on scanning.
Okay, also I notice on the scan here, I see a scan line and I see a dot. What's that?
Right. What the dot does is it shows me what the mid-range of the field of view is. So what I'm going to do here is I want to line up the line with the dot. That means I'm in the middle of the scanner's field of view. And I'm just going to click the record button on the arm and drag the laser scanner across the part. We call this painting the part. And you can see it's very similar to spray painting. And this laser scanner takes data at 30 hertz, which is 30 lines per second. And it has 1,000 points per line. So that gives me a total data acquisition rate of 30,000 points per second.
Okay, and it's taken us, what, maybe a minute to scan this part?
Oh, maybe not quite. Okay, so I'm just going to continue here to fill in the holes and gaps that might be there in the data.
So you just want to make sure that you completely cover the surface of the model?
That's correct. The system also has an auto zoom feature, so you can see that the data rotates automatically and follows the perspective of the laser line.
So you can always see on the screen what it is you're scanning.
Well, and more importantly, I can see where I need to fill in just by moving the laser line to that area of the part.
Okay.
So I'm going to tap a button and say that I'm done collecting the data. Put the arm up.
So now we have our raw point cloud, right?
That's correct. This is my point cloud data, and you can see that it's really actually pretty good data, and that is a result of having that auto exposure setting for the part. If I wanted to, what I could do now is I could edit the point cloud data. So I could select it, come up here to my cloud menu, and select the clean function, and just click and choose the data that I want to delete.
So you're just getting rid of any outliers or features that you don't want included in the finished scan? Is that right?
That's correct. Or if my part was fixtured and I wanted to remove the fixture from the data, I could do that as well.
Okay.
So I'm just going to select that, say OK, and it gives me some nice clean data. I'm going to show you a reverse engineering process. So the first step of that was actually collecting the point cloud data. The next thing I'm going to do is to select that point cloud data and then create a mesh. And then after that, I'm going to use the mesh data to create surfaces that I can pull into a CAD package.
Okay.
So here.
So this is kind of a three-step process. You're getting your raw data, creating a mesh, and then creating the patches?
Yes, that's correct. And the nice thing about this software, PC Demus Reshaper, is that it allows me to perform those steps quickly and easily. So I have the point cloud selected, and because I'm using the RS1 scanner, I can come up here to the RDS scanning function, and I can actually generate a mesh with one mouse click. The reason I can do that is because the software knows the properties of the scanner and also knows the properties of the point cloud data, and it can use those to automatically choose the correct parameters to create the optimum mesh. So I'm going to click that button and set my max triangle value here and go ahead and start to create the mesh. The system creates the mesh in a few different steps. It first creates a rough mesh, and then it refines that and gives me the optimum mesh.
Now it created that mesh pretty quickly.
Very, very quickly. That's typically a process that is very time consuming. And in this case, it created that mesh very quickly. And you can see here I have a mesh of the entire part. Now, even after I've created the mesh, there may be some small imperfections. And PC Demus Reshaper lets me correct those. So if I zoom in here on my part, you'll see in this area I have an imperfection. So I want to fix that before I create my surfaces, because my surfaces are only going to be as good as the mesh I created. So I'm going to come over here and select the mesh and come up to my mesh menu and choose the smoothing tool. And I could smooth the entire mesh, but I just want to work on this one small area. So I'm going to select that and then just select around the imperfection. And notice that I'm selecting some of the good data as well. What the system will do is it will go ahead and look at the edges or the boundary of the area I selected and use that data to continue that surface over the imperfection.
Okay, so it's assuming that the data surrounding the imperfection is the data that you want to basically copy, right?
That's correct, around the edges.
Okay.
So I have the mesh all cleaned up. My next step would be to place contour lines on the mesh. These lines would be projected directly onto the mesh. And the reason I want to do that is the contour lines are actually going to be the B-splines that I'm going to import into my CAD package. And where the B-splines intersect to form valid four-sided patches, that's where I'm going to get a surface that I can then pull into my CAD package.
Okay.
So there are many different tools that I can use for creating those curves. I can come over here to the contour tool and I can do cross sections. I can do a free-handed cross section. You can see it's just as easy as just drawing basically right on the mesh. I can also follow a contour of the curve or put contour lines tangent to a radius, which is a really nice feature that's used very often. Okay? So I go ahead and I complete the model, and I have all of my contour lines here that are placed on the model. And then after that's done, then I select all the contour lines and the mesh, and then from this I'm going to generate the B-splines and the patches. So I have that selected. I'm up here to the CAD menu, and I'm going to choose patch from a set of lines. The system will go ahead and create the different patches and the B-splines, and now this is the data that I can pull into my CAD package.
And how would you get it into your CAD package?
What I would do is I would select the B-splines and then select the patches, and then I could just come over here to the menu and I could go ahead and I could export those, and my export capabilities are either STEP or IGES.
Okay, so what we've seen is going from a point cloud to a mesh to patches ready to be exported into your CAD program.
That's correct. That's the process I would use for reverse engineering using the ROMER 7-axis absolute arm with fully integrated laser scanner and PC DMIS reshaper.
Okay. Let's see. Yep. Okay, this one is from Brian. He wants to know how do the arms mount to a workbench? Magnetically?
Yes. Every arm has a magnetic base that's included with it, and the arm just connects to the magnetic base with a puck, and you can just apply the magnets, and your arm is ready to go.
Somebody has a question about the. Does it have a controller box? Are we seeing the whole thing right there?
Yes, it does not have a controller box. Because the scanner is fully integrated, it doesn't need it. The only thing that is connected between the arm and the computer is a direct cable. No controller box necessary.
Okay. I think this is the last question we have time for right now, is how often do you need to calibrate the scanner?
Well, not very often, if at all. Since the scanner is integrated with the arm, it's fully calibrated at the factory with the arm. But we also provide a certified artifact with the scanner, so the user can check to see if the scanner is measuring within spec before he starts his measurements. And if it's not, it's a very quick, about 2-minute process to recalibrate that scanner.
Okay. Well, Uta, it looks like that's all the questions for you right now.